Hello, good morning to all of you. Welcome to the lecture series on the electrical engineering. Here now I'm going to start my first lecture on the electromagnetic field theory, that is called lecture number 1.1. And it's in this lecture we are basically going to discuss the introduction to the vector calculus, the first part, the unit vector, and then we can switch to the different coordinate systems in the EMFT theory. So before starting the actual concepts of the EMFT, we have to learn some basic concepts which is very useful to understand the concepts of the electromagnetic field theory. So let's start with a two basic concepts that we have already known, that we are calling as a scalar quantity, and second is the vector quantity. So the term scalar, it is being represented here, which can be said that scalar quantity is a quantity whose values may be represented by a single real number or a specific value which may be positive or negative. What is the significance of a single real number? What do you mean by single real number? That means it's having only the magnitude, but there is no direction that can be specified at any particular point in space. For example, we are taking an example of temperature of the atmosphere. We know that in any room or any space or a region, the temperature is basically doesn't having a direction, but we can feel it, we can observe it, and we can measure it in a magnitude wise. Having 20 degrees centigrade, let us suppose 20 degrees centigrade, 30 degrees centigrade, or maybe whatever it is, but it doesn't having direction. That means it's having a scalar quantity. Similarly, when move on to the sound intensity in the auditorium or in a room or in any space or region, the sound intensity doesn't have a direction, but it's having a magnitude which can be heard by our ears. Similarly, the third example is very simple. We are calling it a light intensity in a room. Light intensity is uniformly distributed in the space or in a region, but it doesn't having any direction. So these are the example of the scalar quantity, that means which having only magnitude. Let's move on to the vector quantity. The second important objective is vector quantity. It is a quantity which is having both magnitude and direction in space or in a region, is called the vector quantity. What do you mean by this? The term is magnitude and direction. It's both having the magnitude and direction. For example, the wind velocity of the particle in atmosphere is an example of the vector quantity. What do you mean? If the wind is flowing in the atmosphere, then it's having a specific direction, whether it is north, whether it is south, east, northeast, whatever it is, and it's having a magnitude. That is called the wind velocity. So this is the example of the vector calculus which having the magnitude and the direction. Similarly, displacement of the flying bird in a space or in an atmosphere or in a region. The displacement of the bird which is moving in a space or in a region is having a specific direction, and it's having a velocity that is called displacement velocity. So this is also another example of the vector calculus. Similarly, the magnetic field which is existing from north to the south region, it's having a specific direction and having a magnetic field having a magnitude. So these are the examples of the vectors and the scalar quantity. That means the basic understanding is very simple. Scalar is having only magnitude, and vector is having a magnitude and direction as well. Okay. Next, move on to the next part, that is called the concept of the unit vector. This is very important part, and it is very useful in all the coming classes in EMFT theory. And unit vector plays a very important role in this vector calculus section. If we are not able to understand the unit vector, then I think it becomes very difficult for us to go forward and try to analyze the more parts in the coming future. So let us understand the unit vector like this. Let us suppose this is a bus which is moving. This is the bus which is moving from this side to this side, and the velocity of bus having 10 meter per second. We know that the bus having a direction which is moving from this side to this side. The bus is moving from this side, from left to right, like this, and having a velocity of 10 meter per second. If we want to define the unit vector, let us take a small part, and the distance is divided into small part. Suppose I am dividing this a distance having a velocity of 1 meter per second. So this velocity of bus, this velocity of bus to the cap is representing as a unit vector. That means it shows the direction. It shows the direction. That means the bus is moving in this direction, but it's having a magnitude of unity. Having a magnitude of unity. This is the significance of the unit vector. That means the unit vector gives the direction and it's having a magnitude of 1. If we are considering about the velocity of the bus having a vector quantity because it's having a direction and having a magnitude, it can be represented as a magnitude of bus multiplied by, or better to use another product, bus is having a magnitude having this velocity, and we have, because it is a vector quantity, so we have to also show direction. So v bus cap represent here, the v bus cap basically represent here, this is called the unit vector. This is called the unit vector. That means if any magnitude is multiplied by a unit vector, then this unit vector represent the direction of the bus or any quantity. Bus is moving from left to right. Unit vector is having the same direction, having a magnitude 1, represents the direction of this bus. Let us suppose if this is the road and there is a car is moving like this fashion. This is the car. I will not able to draw this. The direction of the car is having like from this side to this side. If I using v car, the vector should be equal to the magnitude of the car, that is called the velocity, and this is the unit vector. This is called the unit vector, which is v car cap. So this cap or this vector, unit vector, basically represent the concept that is called direction. So we can say that in general, we can say that any quantity having, which is vector quantity, can be represented as a magnitude and having a unit cap. A unit cap represent direction having a magnitude of 1. If I just calculating the unit vector, then we can say that it should be a vector divided by the magnitude a. Okay, so this is the concept of the unit vector, and in short we can say that the unit vector represents the direction of the vector quantity. It's having a magnitude which is equals to 1. Okay, now next to move on to the part that we are going to discuss, that concept we are going to use, that is called introduction to the coordinate system. In the vector calculus, we are having a 3 coordinate system. The first is called the Cartesian coordinate system, the second is the cylindrical coordinate system, and third one is called the spherical coordinate system. And we have to discuss each separately because it is very important in the coming few lectures. So let's move on to the first part, that is called the Cartesian coordinate system. The Cartesian coordinate system can be represented as a system which is called XYZ, or it is another name which is called rectangular coordinate system. Let us draw. If I take this is the coordinate system which having a x, here I am taking the x, here I am taking the z, here I am taking the y. Okay, z, x and y, where x is a point which is perpendicular, which is basically a perpendicular point to the yz plane, which is in or out, which is outside the surface or inside the surface. So we can say that it is the third, it is a 3D system which having x is having a perpendicular to the xyz. If we want to define the unit vector or the base vector in the xyz plane, so we have already learned that the unit vector is a vector which shows direction where the velocity is moving or the object is moving. Here we can say that the x is moving from this side, the y is moving from this side, and z is moving from upward side. So its unit vector can be represented like this fashion because it shows the direction. You can say that it should be a z cap, it should be, we can say that a y cap, and we can say that it should be a x cap. So we can say that a x cap, a y cap, and we can a z cap is called a unit vector. We can say that it's a unit vector which is along the x-axis. Similarly, it's having a unit vector along y-axis. Similarly, it is a unit vector along z-axis. That means the x is increasing in this direction, z is increasing in this direction. Similarly, and the y is increasing in this direction, and this unit vector just only represent the direction where the object is moving or the object is increasing. This is the base concept. Okay. So now let us define this xyz like this fashion. We can say here this is z, this is y, this is x, which is perpendicular to each other. And if I draw the cube to represent any point like this, we can draw. It should be like this. This is the point P, assuming the point P which is in the x direction, which having a x coordinate, y coordinate, z coordinate. So this should be a x, y, z. The point P is placed where we are having a x, where we are having a y, where we are having a z. If I take this plane, only z and y, then if I taking a point P, so we can say that it should be 0, y, z. Similarly, but here we are taking a point which is a corner of this cube, where we are having a x, y, and z. So if I considering this cube is having the 6 faces. This is the face 1, that is called the front face. This is the face 2, which is called the back face. This is the face 3, the left, face 4, the right, and we can say that this is the face 5, the top, and face 6, the bottom. There are 6 surfaces in the xyz coordinate system. Here we have seen. And if I try to draw this face independently, then we can say like this. Let us suppose this is the plane which is like this fashion, and here I am drawing a system like this. It is like this. This is z, this is y, this is x. So this plane which is perpendicular to the zy plane, so this is, we know that this is called x becomes constant. X is constant everywhere. This is the plane which is perpendicular to the xy plane is called x equals to constant. Similarly, if I take a example of this like this, let me draw it. Like this we can draw. If I take a point, it is moving like this. Okay, I think it should be completed. This is z, this is y, this is x. This is the plane which is perpendicular to the xy plane. So we can say that this is the plane called z equals to constant, because the z is constant everywhere, and which is perpendicular to the xy plane. And there is one more plane is there, that is called, we can say like this fashion. Okay, and we can say like this. It is moving. Like this fashion, we can say. This is z, this is y, this is x. Here we can say that the plane which is perpendicular, which is parallel, I am so sorry, which is parallel. The plane which is parallel to the zy plane is called x equals to constant. The plane which is parallel to the xy plane is called z equals to constant. and the plane which is parallel to the xz plane is called y equals to constant. Okay, so these are the three planes that we have already seen, and we can easily understand in the we can use this concept in the coming the classes. Okay, now let's move on to the concept that we are called positions or distance vector. Position or distance vector. Okay, it can be represented like this. Let us consider a point which is in the cube. We have already drawn it. Let's redraw it for the sake of explanation. You can see like this. Should be. It is very simple concept. Consider a point P which having a coordinate x, y, z, and if I want to find the distance, the position of this point from the origin which having a coordinate 0, 0, then what we can do, we can just using the formula. It is very simple. Since we are moving from 0 to P, so this vector is called OP vector. So OP vector is nothing but, we can say that it should be x2 minus x1. It should be a x cap because it's having, this is the unit vector of the ay, this unit vector for the a x and this is for a z, plus we can say that the y2 minus y1, it should be ay cap plus z2 minus z1, it should be az cap. Okay, so here we can say that the OP vector is equals to x2 minus x1 is x, a x cap plus y, a y cap should be z, a z. This is the OP vector which having a direction like from O to P and having a magnitude of x square plus y square like this. So if you want to draw the magnitude, then we can say that it should be x square plus y square plus z square. This is called the magnitude. Similarly, if I consider in another case, let us take a 2 points. Let us take like this. If we want to find the position of the 2 points, like this is the point 1 and this is the point 2, this is the point P1, or let's say P, better to say P, it's having a coordinate x1, y1 and z1, and this is the point Q which having a coordinate x2, y2 and z2, and we have to find the distance that is from P to Q. So what we can do, just we can assume the distance OP having direction this, having a OQ like this. So if we are moving from O to P and O to Q, and so this is basically like this. This is O, this is P, this is Q. This is the OP vector because we are moving from O to P having direction OP. We are moving from, this is PQ vector, and this we are having from, this is OQ vector. If I write the equation of first OP vector, so it should be ax1 ax cap plus y1 ay cap plus z1 az cap. If I write the equation for OQ vector, it should be x2 ax cap plus, sorry, this is y2 ay cap plus z2 az. If I using the vector identity, so we can say that the OP vector equals, sorry, OP vector plus OP plus PQ vector, it should be equals to the OQ vector. If I want to find from P to Q distance for the vector quantity, we can say that it should be OQ vector minus OP. Put the values of OP and OQ and we can find the relation that we are calling. It should be x2 minus x1 should be ax cap plus y2 minus y1. It should be a by cap plus z2 minus z1. It should be z. If I just try to find the magnitude, it should be x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square to the 2. So with this concept, we can calculate the distance between the 2 points, or we can say that the distance between from 0 to the peak Q point like this. So these are the elementary concept for the Cartesian coordinate system to find the distance from 2 points or between the points. Okay. So this is the first lecture that we have understood. Okay. Next, move on to the very important part. It is called the differential elements in the Cartesian coordinate system.